All right, so we're going to start with inductive and deductive reasoning. We want to know what the next three numbers are in this sequence and why. So 2, 4, 6, 8. And it's pretty obvious that it's 10, 12, and 14. All right, so those would be our next numbers of 10, 12, and 14. And the reason this would be is because we can see that each number is skip counting by 2. So what type of logic did we just use here? Well, let's take a look. Okay, we used inductive reasoning. It's a form of reasoning in which a conclusion is reached based on a pattern that's present in numerous observations. So typically a question I would ask is, well, what other school subject do you use this in? And then in a job application, what kinds of jobs would use inductive reasoning? So other than math, which we just used it, science uses inductive reasonings when you are working with experiments. You do trials or experiments, and you record all the observations that you make with them. And you come to a conclusion that if an experiment behaves a certain way most of the time, if not all of the time, then if you were going to do that experiment again, you would expect it to have the same conclusion, all right, following the same pattern. That's inductive reasoning. Detectives use it. Police officers use it to fight crimes. Lawyers use this inductive reasoning also. There's plenty more. Medical research uses it. There's so many careers that use inductive reasoning. And of course, we use it on a pretty ongoing basis, and we don't realize what it's called. All right, so our conclusion that we used, that we reached using inductive reasoning is called a conjecture. Okay, so that's our conclusion. It's a fancy name called conjecture. Now, if we're trying to see if something can always be true, we always kind of look to show if a conjecture is false. And if we can find just one example that a conjecture or a conclusion could be false, that's called a counterexample. And we would have to explain or write out what that counterexample is in order to prove a conjecture to be not true. All right, so let's look. We have a statement, people walking outside are using their umbrellas. Well, what conclusion can be stated and why? So give it a few minutes of thought, or pause the video if you want to before you reach the answer. And let's look. Well, it could be raining outside, or it could be snowing or sleeting or hailing, or it could be sunny out and people are using the umbrella to block the sun. Okay, and that should be a C, so I apologize for my typo I didn't catch beforehand. All right, but we should change that right now so that we are grammatically and correct. So that's a C, could. All right, so there's plenty of people who walk outside with umbrellas if it's sunny because they don't want the sun on them. They don't want to get sunburned, okay? So that there are plenty of reasons of why that can happen. All right. Let's get our mouse back here. Now, what you used here is called deductive reasoning. And that's a form of reasoning by which each conclusion follows from a previous one. So if you know that people are walking outside and they're using the umbrellas, then we can make many conclusions, like it could be raining or snowing, or it could be sunny and people just don't want to get the sun on them. So a form of reasoning by which conclusions follow from a previous one is what we call deductive reasoning. You have an argument that's built by conclusions that progress toward a final statement. And again, all the professions I just had mentioned also use deductive reasoning. Okay. All right, so our conclusion here is based on facts. What we see people using their umbrellas. So we use deductive reasoning to reach a valid conclusion, and those conclusions are correct and they are valid, meaning true. So The difference between inductive and deductive reasoning is that inductive reasoning is used to form a hypothesis, such as an experiment. We try it, we try it, we try it, we try it in an experiment many, many times, many trials, and we see that the same thing is happening over and over again, or most of the time that same thing is happening over and over again. So therefore, we form a hypothesis and we say, because of reason A, conclusion B occurs. Deductive reasoning uses more extensive reasoning in the fact that we look and see what's already there, and we reach conclusions based on that, such as the people have umbrellas up. Well, the conclusions we can reach are numerous. It could be raining, snowing, sleeting, hailing, or the sun could be out and people just don't want the sun on them because it's very warm. They're trying to protect their skin or something like that. So deductive reasoning is mostly used in geometry, and it's used to prove ideas. And this is where we come into using our deductive reasoning skills for proofs. We make a statement and we come up with a valid reason as to why that is happening. Umbrellas are up, valid reasons that could occur. It's snowing, sleeting, hailing, raining, or the sun is out and people don't want the sun on them. So we start with a statement of fact. We see the umbrellas up, that is a fact. You cannot say they're down when you see them up, that's a fact. So therefore we use a reason, we get a reason to justify why that has happened. And that's the difference between inductive and deductive reasoning. Some terms we need to know are axioms. Axiom is a statement about real numbers that is accepted true without any proof. A postulate is a statement about geometry that is accepted as true without proof. A theorem is a statement in geometry that has been proven. And undefined terms are terms that are not defined, but instead they are explained. They form a foundation for all our definitions in geometry. So we're really going to work a lot with theorems and postulates, and those are going to be our reasons for the statements that we're going to make in our proofs. So we're going to wind up doing a lot of logic and reasoning skills practice before we write proofs, but these are the terminologies that you are going to be using, and the type of reasoning you're going to use is predominantly deductive reasoning. A fact will be stated, and you will justify it with a reason. And that concludes our lesson for today.